So this video is integrated to chapter 8, D-Day number 2. So in this first problem, we have a sector, and we want to find the area of the sector and the arc length of the sector. Okay, and we want to leave our answer in pi. So on this, what we want to do is let's first talk about the area of the whole entire circle. So the whole entire circle would have an area of pi r squared, where r is your radius. And in this case, my radius is 11. So the area of the whole entire circle is going to be 11 squared, or 121 pi. Okay. Now we don't have all of it. We're going to have part of it. We'll talk about that here in a second. We also want to look at circumference. Circumference would be all the way around the circle. What I just drew right now is your arc length as part of your circumference. Now circumference is going to equal 2 pi r. If I put in my r, I'm going to double my r, which really is my diameter. So my diameter is 22, so 22 pi. And again, that is going to be our whole entire circumference. We have part of it. So I'm going to take both of these answers and I'm going to take the part I have. So I have 110 out of 360 degrees. So 110 degrees out of 360 degrees times 121 pi. And I'm going to work that out. For my circumference, I have 110 out of 360 times my circumference, which is 22 pi. And we're going to work that out. So I am going to bring my calculator over here. And I'm going to do alpha y equal to get fraction. And I'm going to do 110 out of 360. Just zoom in a little bit more. Times, I'm not going to put in the pi, I'm just going to put the 121, and I get 1,331 out of 360 pi. And that's going to be my area of my sector. And I'm going to take the same thing, 110 out of 360, and I'm going to be multiplying it by 22 pi, but let me multiply by 22, and I get 121, so 121 over 18 pi. And actually I'm going to put the pi in the top with both of them. And that's my answer. Okay, on number 2, and let me just say, well, they didn't give us any units here. So my area would be square units and my arc length would be just regular units. Okay, on number 2. So I'm looking at this side here, which is 12, and this side here, that's 6. So you can think of 12 over 6, which is 2, or 6 over 12, which is 1/2. Again, I'm still taking the sides that are corresponding, and I'm setting a ratio. Now, if I'm going from my bigger one to my smaller one, I would have been multiplying it, all the sides, by 1/2. If I am going from my smaller one to my bigger one, I would have multiplied everything by 2 in terms of sides. Okay, so I'm going to think of this as a ratio of 1/2, because my area of my bigger one, I shouldn't say area, my size of my bigger one, all the sides are going to be half as much. So this is 12, half of 12 is 6. Now, when I'm talking about area, okay, I'm going to take this area, which is 36, and I am not going to multiply that area by 1/2. My area is 1/2 squared times it. So this is really going to be 36 times 1/4, which is going to be 9. So this is going to be 9 square units. On number 3, we want to find the area of a hexagon. So I'm just going to grab a hexagon here. And take one of these and add it here. So I have a regular hexagon. Okay. And what's going to be happening for this is when we're doing this, all the sides are going to be 16. Okay, 16 all the way around. Now, what I am trying to find is the area. So when I have my center of my hexagon and I draw out to each of my vertices, I am going to get 6 triangles. Now, these triangles are for sure isosceles. Okay, that's always true for any regular polygon. But in this one in particular, my central angle, if I take 360 degrees divided by 6, I get 60 degrees. Each of these is 60 degrees. So if that's 60, and the rest of the triangle, the 2 bottom bases together is 120, but it's isosceles. So 60 and 60 is what these are going to be. So I actually end up with an equilateral. You always end up with an equilateral for a regular hexagon, not for any other shape. Okay, so let me just get a triangle. Okay, so I've got my triangle, and this triangle is equilateral. So what that means is if this is 16, this is also 16, for example. And what I do need to find, this one's actually kind of nice because I know my base. So I know if I split this in half that I have an 8 and an 8. I also know that that angle at top, that was 60. When I split it in half, it is now going to be a 30, and this is a 60. And so I have a 30, 60, 90. So I am going to take this length here, which is 8. And I know that for a 30, 60, 90, that the side across from my 30, if I take that, which is 8, to find the one across from my 60, it's going to be that times root 3. So that's an 8 root 3. So now when I'm trying to find the area of one of these triangles, I am going to take 1/2 times my base. And when I say base, we're talking about the whole thing across, which is 16, times my height, which is 8 root 3. This would be one triangle. I have 6 triangles. So I am going to multiply this whole entire answer, once I get it, by 6. Okay. So I am going to put this into my calculator. And I'm going to do 6 times 1/2 times 16 times 8. I'm not going to put in my root 3. So I know I'm going to get 384 root 3. 384 root 3. And that is centimeters squared. Okay, centimeters squared in terms of units. Okay, on number 4. So on number 4, calculate the area of a regular octagon. Okay, so this one's going to be a little trickier. We have 8 triangles here. So this triangle right here is going to be isosceles. Both sides of this are going to be 17, but this base is not going to be 17. Okay, so when I take 360 degrees divided by 8, okay, I take 360 degrees divided by 8. I end up with 45 degrees. So this right here is 45 degrees. So when I take that triangle, okay, so when I take that triangle, and again, this right here is 45 degrees, with this being 17, I need to find this height and I need to find this whole base, okay? So I am going to take half of 45, which is 22. And so when I take my triangle and I am thinking about half of it, again, this is going to be 17. This angle here is going to be 22.5, 22.5. I do not know this and I do not know this. So I am going to take from this angle, the x is opposite, my 17 is my hypotenuse. So that is going to be sine. So I am going to have sine of 22.5 degrees is equal to opposite over hypotenuse, which is 17. I am going to multiply this by 17, multiply this by 17, and I am going to get 17 sine of 22.5 degrees is x, okay? So that answer there, just so we all understand, this answer here is this distance right there, just to here. So if I want to go all the way across this bottom, I don't have 17 sine 22.5. I have double that. So I have 34 sine of 22.5 degrees. Okay, that is my whole base. Now to find my y, I am going to use cosine this time. So I'm going to have cosine of 22.5 degrees equals adjacent over hypotenuse. I am going to multiply both sides by 17 by 17. And I'm going to get 17 cosine of 22.5 degrees is my y. So this distance right here is this. So to find the area of my whole entire triangle here, I'm going to take 1/2 times my base, and my base is the 34 sine of 22.5 degrees, times my height, which is 17 cosine of 22.5 degrees. And that's one triangle. We have 8 of them. And so I'm going to put all of this into my calculator, making sure that my calculator is in degrees. Okay, so 8 times 0.5 times 34 sine of 22.5, close that parenthesis, times 17 cosine of 22.5. And I'm going to end up 817 point, let's say 42 centimeters squared. That is going to be our answer. Okay. Next problem. On number 5. So when I am doing this type of a problem, the numerator is the power. So we're squaring. The denominator is the root. So I am going to take the cube root of 8. Then after that, I'm going to square that. So the cube root of 8 is 2. And 2 squared is 4. And that's my answer. On letter B, I'm going to be multiplying my numbers together, my A's together, and my B's together. So when I do 4 times 4 times 5, 4 times 5 is 20. When I do A times A to the 4th, I add the exponent. So 1 plus 4 is 5. When I am multiplying my B's together, I'm going to add -3 plus 8, and I get a 5. And that's my answer. So I have 20, A to the 5th, B to the 5th, and that's my answer. On C, everything in the parentheses being raised to second power. So just so everyone understands, 6 is being raised to second power, my x to the -3 being raised to second power, and my y squared is being raised to second power. So 6 squared is 36. When I have power to power here, my -3 and 2, power to power, we multiply. So we're going to get x to the -6. Again, here, power to power, we multiply. So we're going to get y to the 4th. We do not like having this negative exponent. So we're going to rewrite it. The 36 and the y to the 4th are going to stay where they are. And the x to the -6, I'm going to move to the bottom, and I make it x to the +6. When I move something from numerator to denominator, my exponent changes signs and becomes opposite. On number 6, this is going to be a 45. This is a 45, 45, 90. So what happens is basically I'm going to take this, which is x. I'm going to times it by √2 to get 10. So another way to think about it, if I'm trying to find that x, I'm going to take my hypotenuse, which is 10, and divide it by √2. Now, that is not my answer. We need to rationalize. So I'm going to multiply the top and bottom by √2. And when I do, I'm going to get 10 √2 over 2. And 10 over 2 is a 5. So I get a 5 √2. And this is a 45, 45, 90. So my x and my y are both going to be 5 √2 because it's an isosceles right triangle. On number 6, if this is a 30, the side opposite end is kind of like the building block. Okay. Another way to think about it is that if I was to reflect this across that line, I would get a 60. I would get an equilateral. So what that means is if this is 8, this would also be 8, and then all the way across would be 8, which means that half of that would be a 4. So what ends up happening every time with the 30, 60, 90 is across from your 30 is your building block. If you know this, you double that and get your hypotenuse. You take this and times it by √3 to get your one across from your 60. So I get a 4 and I get a 4 √3. On C, this one is a mid-segment problem. So this is a midpoint. This is a midpoint because this is split into 2 equal pieces and this is split into a different 2 equal pieces. And that segment across is from connecting one midpoint to the other. It's called a mid-segment. So what is true is the smaller triangle here compared to this bigger triangle. This bigger triangle is, because of this being a midpoint, 2 of these, so it's twice as big. 2 of these, so it's twice as big. So that's true of both triangles. If I double the sides of this, I get the bigger one. So this base angle of 4x plus 5, I am going to double. So I'm going to take 2 times 4x plus 5, and I'm going to set it equal to 6x plus 20 and solve. So I get an 8x plus 10 equals a 6x plus 20. So when I solve this, I'm subtract 6x from both sides, and I'm going to get 2x plus 10 equals 20. I'm going to minus 10 from both sides and get 10, and divide each side by 2, and I get 5. And one way to double check this is if I put 5 into this first one, I'm going to get a 25. If I put 5 into the second one, I'm going to get a 50. See how it's twice as big. Why? The mid-segment neuron. That is why. Okay. On the next letter C, there's 2 letter C's. We have 1, 2, 3, 4, 5, 6 sides in this. So I'm going to do 6 minus 2 times 180. So basically 4 times 180. And so when I do 4 times 180, I end up with 720. That's one formula where you take your number of sides minus 2. You always have 2 less times 180. Or another formula is we have 6 sides, so times 180, and then I'm going to minus 360. That's another formula. So if I go 6 times 180 minus 360, you see I still get 720 in both cases. So now what I'm going to do is I'm going to add up all of these and set it equal to 720. So let's see. Let me just take my numbers. So I have an 80, a 135, a 50, another 130, a 75, and a 115, which together is going to give me 585 plus my x's. I have x, 2x, 3x is equal to 720, and I'm going to solve. So I'm going to minus 720 minus 85, and I get 135. I'm going to divide that by 3, and I get 45. Now my justification, the sum of interior angles of hexagon is equal to 720 degrees. Okay, that's what allowed me to write that equation. Okay, next one. This one, let's just double check. Looks like a pentagon. 1, 2, 3, 4, 5. So it is a pentagon. So I'm going to go 5 minus 2 times 180, or 5 times 180 minus 360. Both of these are going to give me the sum. So if I basically do 3 times 180, I get 540. If I do 5 times 180 minus the 360, I also get 540. So I'm going to set an equation, and I know that the pentagon sum of interior angles is equal to 540. So something else I need to do, I don't know this angle, but I know together if I take 180 minus 67, 180 minus 67, it's going to give me this angle, which is 113. So now I'm going to add up all 5 of these angles. And I say 5, don't forget that this one is a 90 degrees. Okay, it is 90 degrees. Don't forget that. So I am going to take 90 plus 3 plus 113, which would give me 206, plus 1x, 2x, 3x. So plus 3x equals 540. I'm going to take 540 minus this answer, and I get 3x is equal to 334. Divide by 3, and I end up getting 111.3 repeating, or 334 over 3. Either one of those would be acceptable. On number 7, for this one, we have a regular polygon that has 21 sides, and we want to know the sum of the interior. So I am going to take 21 minus 2 times 180, or 21 times 180 minus 360. Both of these equations work. So 21 minus 2 is basically 19 times 180, which is 3,420. 21 times 180 minus 360. Again, we end up with 3,420 degrees. So either one of these ways is correct. What is the measure of an interior angle? So if I want one of them, I'm going to take 3,420. They're all equal in this case because it says it's regular. And I'm going to split it into 21 pieces. So 3,420 divided by 21. And I get 162 point, let's say 86-ish. Okay. Is that answer? If I hit math, change it to a fraction, I get 1140 over 7. That's it exact. Okay, but this is it as an approximation. Okay. What is the measure of an exterior angle? So what I'm going to do is I can do 180 minus the answer I just got. Okay, so if I have it rounded, it's that. But I'm going to have it in my calculator. And so I'm going to do 180 minus, and I'm going to come up here and steal that. And I get 17.14 degrees. I could also have taken 360 and divided it by 21. And 360 divided by 21 is, again, is 17.14 degrees. I can get it both ways. On number 7, we have a regular polygon with a 140-degree interior angle. How many sides? So what I'm going to do is I am going to think about if this is 140, then my exterior angle is going to be 40. Okay, this is my exterior. This one would be my interior. And right, so that's not what they're asking. Well, I know that the sum of all exterior angles is 360. So if I take 360 divided by 40, I see that I'm going to have 9 sides. Okay, so this is 340 degrees divided by 40 degrees. I end up with 9 sides. Okay, that's how many sides. What is the sum of the interior angles of the polygon? I know that one interior angle is 140, and I have 9 of them. So I'm going to take 140 times 9, and I get 1,260 degrees. What is the measure of an exterior angle? I found that answer here. Okay, it is 40 degrees. Okay, on number 9, the perimeter of a polygon is 280. It's a regular polygon, so all the sides are the same. And exterior angle is 9 degrees. So if I take 360 degrees, which is the sum of all exterior angles, and divide it by 9 degrees, I'm going to have 40 sides. Okay, 40 angles, so 40 sides. So if I take my 280, which is my perimeter adding all 40 sides, and I split it by 40, each of those is going to be 7 feet. Okay, on number 10, we have a circle that is inscribed, it's touching the sides. So that means my diameter is 7 for that one, and my diameter is 7 for this one. So that also means that if I'm going this direction, this is also a diameter of 7, and this is also a diameter of 7. So this is going to be 14 going all the way here. So for my rectangle, I'd have 7 by 14, and 7 times 14 is 98. For my circle, okay, I'm going to have 2 circles, but each circle is going to be 7 all the way across. So it's going to be 3.5 across for my radius, okay? And so I'm going to have pi times 3.5 squared. So if I take 3.5 and square it, I'm going to get 12.25 pi. Now I have 2 of these, okay? So each of these is going to be 12.25 pi. So if I double this, I'm going to have 98, which is the whole entire thing, minus my 2 12.25 pi's, which ended up in 24.5 pi, and that is my answer.